Rolling peaceful through the night with DINGLE. Hello everyone, we are Team C from the Embedded System class. We developed DINGLE, a smartphone baby monitoring system that analyzes crying sounds using CNN and detects infants' pause for safe parenting. Before we begin, let's take a look at the video. Raising a newborn comes with many challenges. First, the risk of falling. You might think a bed rail is enough to prevent falls, but as this video shows, accident can still happen even with safety measures in place. Another major danger is suffocation, which is one of the leading causes of sudden infant death syndrome. It often occurs when a baby sleeps in an improper position, especially when lying face down. Parents must constantly monitor the baby's posture, which adds a stress and burden. Babies cry for many different reasons. Experienced caregivers may distinguish between cries, but first-time parents often struggle to understand what each cry means. As you can see, new parents face several anxiety, such as sudden infant death, unsafe sleeping position, and trouble understanding their baby's needs from crying sounds. That's why we decided to build a particular service that eases these challenges and truly supports first-time parents. Introducing our solution, DINGLE. Using AI, DINGLE analyzes crying sounds and prevents potential suffocation or falls, helping parents monitor their baby's health and safety in real time. DINGLE uses a camera installed near the baby to collect data and deliver that information to the patients through our system. This connects babies and their caregivers through one reliable channel. DINGLE offers three core features: crying sound analysis, AI-based fall and suffocation alters, and statistical reports based on collected data. To develop DINGLE, we built a system based on this architecture. Voice and video data are analyzed on AI server to detect dangerous situations, and notifications are sent to caregivers. Our data is stored in AWS using MySQL and 3S, and our CI/CD pipeline ensures smooth operation. Now let's dive in one of DINGLE's core functions, crying sound classification. We can use the donate cry dataset and apply the FFT-based audio analysis to convert baby cries into spectrogram, which are then classified using a CNN model. You might wonder, can a baby condition really be determined for crying? As you can see this image, different emotional states produce distinct frequency patterns. Using this, we classify cries into categories such as hunger, discomfort, pain, pumping, and sleepiness. We use the Donate a Cry dataset, collected through a global campaign. To make the model applicable to real life, we supplemented the data with everyday noise sample from AI Hub, allowing us to train under more realistic conditions. To progress the audio data, we condition two methods, FFT and 3D feature vectors. We choose FFT because it's fast, works well with simple frequency patterns, and requires less computational power and storage. It suits our preprocessing needs perfectly. We then trained our model using a CNN architecture. Here is the final structure of our CNN model. We achieved a high accuracy, about 96.5% in classifying the baby's emotional states from their crying sounds. The second core feature of DINGLE is fall and suffocation detection. We analyze the reliability and position of positional key points to determine if the baby is face down. For fall detection, we compare the baby falls key points with the best boundary to assess risk. To implement this feature, we use the COCO dataset, which includes various object and human pulse information. Each detailed annotation made it easier for analyzing infant's posture. After collecting the data, we performed filtering, labeling, and augmentation. Data refinement improved training reliability, and augmentation helped enhance the model diversity and performance. We combine YOLO VA segmentation and pose models to accurately detect the baby's position and posture. First, we use the segmentation model to identify the baby and bed boundaries. Then, using the bed segmentation mask, we calculate the bed's coordinates. Next, the YOLO V8 pose model analyzes the baby's posture and detects risk of suffocation or falling. If posture key points are not detected for more than 90 seconds, the system assumes the baby is face down, indicating a suffocation risk. For earth detection, we check whether the baby's key points are outside the bed boundaries. To optimize the model for real-life use, we improved performance in two ways. First, we pre-separate video frames on the server, reducing analysis time by about 1 second per frame. Second, since the system was work 24/7, including at night, we improved low light detection accuracy from 40% to 70%. Based on these optimized models, we developed the backend system to support our service infrastructure. Now, let us show you a demonstration of the DINGLE baby monitoring service. When you open our app, a login page appears. After signing up and logging, you can enter your baby's information and your phone number. This number may later be used for emergency calls. Since we cannot demonstrate with a real baby, we will upload pre-recorded video on a different device. First, let's see a suffocation risk scenario. The system alerted us about the risk, and we can see the baby is lying in a dangerous position. Next, let's upload a different video showing a full risk. Again, we receive an alert and confirm the risk through the monitoring page. Although the actual video is uploaded on another computer, the server processes the video and sends an alert in real time. Parents can view the notification and respond promptly. We also plan to implement features such as baby condition logs and daily statistics. As now the test crying detection feature. We will upload a crying sound Dingle tells us the baby is sleepy. Let's try another sound. It says the baby has a stomach ache. Uploading the sleepy sounds again, we can confirm once more that the baby is indeed sleepy. Dingle allows parents to monitor, understand, and care for their child with confidence. DINGLE we expected the following benefits. Compared to existing service, DINGLE stands up by offering more detailed classification of baby conditions and higher functional usefulness. We aim to strengthen our position through this unique advantage. Over time, we will utilize the collected data to analyze sleep quality and provide meaningful statistics to parents. Our goal is to reduce parenting stress and prevent accidents, ultimately evolving DINGLE into a smart baby care service. Now, let us introduce our amazing team. We collaborate across AI, front-end, and back-end roles to complete this project. Each member will briefly share their thoughts. Seong said it was meaningful to apply CNN and YOLO models to a social impactful project. Hyuntaek shared that this project helped him appreciate the value of YOLO once again. Yoon said that developing an AI-based service improved his understanding and skills in both AI and software development. To conclude, we believe that children are our future and their parents are building dreams through them. With DINGLE, we hope to ensure a safe and peaceful sleep for babies and offer busy parents a moment of peace. Thank you for listening to Team C's presentation.